This is Module 25 of Mechanics of Materials, Part 1. And the learning outcome today is to find the stress on any given plane at a point for a given set of plane stress conditions. And so here was our development of Mohr's circle that we did a couple modules ago. And then last module, we solved this example with actual numbers. And we found the principal stresses, sigma sub 1 and sigma sub 2, and the maximum shear stress, and we also drew it on a properly oriented stress block. Today we're going to look at the normal stresses and the shear stresses on plane AA on our stress block. And so we'll start by finding out what this angle theta sub A is on our stress block. And so we have theta sub A is equal to, that's going to be the opposite over the adjacent, or the inverse tangent of 3 over 4, which ends up being 36.9 degrees on the stress block. But we know on Mohr's circle, that's going to be 2 theta sub A. And if we round off to 3 significant figures, that ends up being 73.7 degrees on Mohr's circle. And so we're going to go now from our horizontal face counterclockwise 73.7 degrees, and this is 2 theta sub A. And this is going to be our point A. And so we now have 2 theta sub A, we have 2 theta sub P. We also, let's look at this angle here, which is phi. I'll call it phi. And so we have phi, which is equal to 2 theta sub A minus 2 theta sub P, or 73.7 degrees minus, if you recall back from last lesson, 2 theta sub P was 22.6 degrees. And so phi ends up being 51.1 degrees. And so this angle phi is 51.1 degrees. Now I can drop a vertical line here, and so I know what this angle is, and now I can find at point A my shear stress and my normal stress at point A. So sine of phi is equal to the opposite side, which is going to be the shear stress at point A, divided by the radius. And we know the radius is 130 from last time. It's also written here. And so we've got tau sub A equals 130 times the sine of 51 degrees, which ends up being 101 megapascals. And so that's one of our answers. Similarly, we can go and find the normal stress at point A. This is the adjacent side. We have the hypotenuse. So sigma sub A is equal to 130, the radius, times cosine of 51.1 degrees. And this should have been 0.1 degrees up here. But this radius, remember now, we want the normal stress from here to here. So we're going to have to subtract out this 20 from our center, and we find that the normal stress at point A is going to end up being 61.6, or sigma sub A equals, and this is positive, so it's 61.6 megapascals in tension. And that's our other answer. So on our Mohr's circle, we can plot it up here. This state of stress for the principal stress condition is 61.6 and the normal stress, and 101 for the shear stress. And you can notice now that for this state of plane stress, you could do this for any plane through that stress block. So you could find the normal and shear stress on any plane. Let's go ahead and draw the stress on a properly oriented stress block. We're moving from our horizontal face here, so this is my horizontal face. I'm going to turn my block. In this case, I've turned it 36.9 degrees. This is 36.9 degrees. And on that face, our stresses are 61.6 normal stress megapascals in tension. And we have 101 and it's positive, so that means it's going to be in a clockwise direction on our stress block. And so our normal stress, our shear stress on that face is 101 megapascals. And so that's the solution. And you should now have a pretty good grasp on how to use Mohr's circle to find the principal stresses, the max shear stress, and actually the normal and shear stress condition for any plane for plane stress at a point. And I'll see you next time.